Now we're looking at the ball script, and it's a very long one. It's the longest one of the program. It has two scripts in the script area. The first one is activated when the green flag is clicked. We have show ball because, as some of us have experienced, the ball disappears sometimes, so it's a scratch bug. So by having the show instruction from the looks area, we're definitely going to have this ball show every time. Now we set the mouse variable to 0. That's the score for the mouse. We set the cat variable to 0, so this is our instructions here, and we just grab these data instructions and we can change what that instruction is for, or what sprite that instruction is for, by using the drop down menu, and then we just drag it in the sequential structure that we've created here. We have the ball go to x0, y0, so that's at the center of the grid. We wait 2 seconds for everything, all the programming elements to get ready, and then we broadcast message 1, so we send the message to everyone. We could have called this anything. We could have called this go or start by just creating a new message name. The default is message 1, so I've left it at that. So message 1 gets sent to another script inside the ball script area. It gets sent to the stage area, so when the game first starts, it plays a little note, and you can change that to anything you like. It does not affect the cat sprite, but it affects the mouse sprite, so the mouse receives a message and it starts. To be a really good programmer, you would also change this to when I receive message 1. Because the fewer green flags you have, the faster the program runs and the more organized it is. So keep that in mind. When you first begin Scratch programming, you tend to use a lot of these green flags. Try to use messages and synchronize the sprites with the message. So this is a better way of programming. Back to the ball script. This begins the script when it receives a message, and if you'll notice, the very first instruction is await. This is a loop instruction. It doesn't look like it, but it actually is, because what happens is that this instruction keeps repeating itself over and over again and won't let the script execute or run the other information in it, because it's waiting for something. What is it waiting for? Touching mouse 1 or touching cat. So if the ball touches the mouse or the cat, then you don't wait any longer. So until that happens, it keeps going back and forth in a circle. And if the ball touches the mouse or the cat, then it breaks out, so the loop finishes and the script continues. Then when the ball is touched, we have a forever loop, and look at this. The forever loop hugs a whole bunch of sequential and decision structures. So this is a forever loop structure, and the first thing that happens is that we move the ball 10 steps, so when it's touched, the ball moves 10 steps, and if it's on an edge, if it hits an edge of the screen, of the stage, then it bounces. And that's an instruction that Scratch created, and it always bounces at the equivalent angle to how it hits the edge. So if you follow the cursor, if the ball hits here, it'll bounce in a similar angle away from it. Next we have a decision structure. If touching cat, so if the ball is touching the cat, in other words, if we've moved the cat and we're kicking the ball with a cat, then if that is true, then do these instructions. Point the ball towards the cat, and we do that to orient the ball so that it's position is the same every time the cat touches it. In other words, that would be its 90-degree or right-facing position. Then we turn the ball around in a random area from 145 to 180 degrees. If you wanted the ball to turn around 180 degrees every time, then you would use simply turn 180. But I wanted to make it more like a soccer game where the player sometimes kicks the ball and the ball goes off the side of the foot. So I've made a random selection here, and we would go to operators to find that, and here's your random operator, and you just pluck that in there, and then you change the numbers. So that gives a little element where you don't know exactly how the ball is going to bounce off of the cat. Then the ball moves 10 steps after you've oriented the ball, and you play the sound pop as if the ball has been kicked. So let's go over this again. The ball points towards the cat, and this is to do with angles. If you look at the information of the ball, you see the direction of the ball points at minus 93 degrees, and that really should be 90. So it's really hard to do on this. There, minus 90. So the ball is turning this way. So this hexagon is always facing that way. So in this case, it's going to be facing the cat. Then we can rotate the ball a certain amount because we know the starting position before we rotate it. So this is the starting position. The ball is facing left. Minus 90 degrees is scratch talk for left. So we point the ball towards the cat. So in other words, this hexagon will be pointing towards the cat, and you can look at the program as you're playing it to verify if that's true, and it is. Then we turn the ball between 145 and 180 degrees. So the ball can turn about like that or about that much. Completely around is 180 degrees. And then the ball moves 10 steps away from the cat. So the cat hits the ball and the ball will move away 10 steps. Then we play the sound pop as if the ball's been kicked. And if it doesn't touch the mouse and it doesn't touch a goal, then it will repeat itself because it's in a forever loop, and the ball will move yet another 10 steps in the same direction that it left the cat. If it's on an edge, it will bounce, and then it will stop. So the maximum that it will move if the cat touches it is 20 steps. So that's one division, 20 steps. If the mouse touches it, this time we have the ball pointing towards goal 1. Goal 1 is over here, so we're helping the mouse aim the ball towards goal 1. We turn the ball 10 degrees, which is a very, very minor turn, and then the ball moves 10 steps. So the ball will leave the nose of the mouse at a very minor 10 degrees. We did this so that if it's 0 degrees, it's just going to go back and forth. If it hits the edge, if the ball leaves the mouse and hits the edge of the screen, let's say it's up here, it's just going to go bounce back and forth. So by making it 10 degrees, you're always sure that the ball is going to bounce away from the mouse if it hits the edge. You may want to change this to a greater degree, because sometimes when you're in the corner here, the ball just keeps going back and forth, and you'll see that when they're playing. So there's lots of improvement that can be done in this game. So you may want to change that to 20 degrees. And we play the sound pop again. So here we go. If it doesn't touch the cat, and if it touches the mouse, point the ball towards the goal, because you want the mouse always to hit the ball towards the goal. Change the rotation by 10 degrees so the ball doesn't go directly into the goal, but it might go off slightly 10 degrees, which is almost the same as hitting the goal. And that's why the mouse is so accurate. Here we have to move the cat, and try and hit the ball on one side of the sprite of the cat so that it bounces off and goes towards the goal. Whereas the mouse always hits the ball towards the goal. That's a very big advantage for the mouse. Then, if the ball actually touches the goal, a score is made. So we hide the ball. We play the sound pop. We change the mouse by 1 because this is goal 1 over here. So if the ball hits goal 1, then the mouse has created a score or made a goal, and we increase the variable mouse by 1. We wait a second. We have the ball go back to the middle position, but it's hidden so you can't see it. Then we broadcast message 1 again. So you see the advantage of broadcasting is that you can restart the program from anywhere inside of another script. And here we are inside of a decision structure inside of a forever loop. And we can restart everything from here. So the forever loop is actually really broken because we broadcast message 1 and we go right to the beginning of the script. And we also go to the other scripts where message 1 is received and things are restarted. So restart the game with message 1, but it does not change the timer. So the timer keeps counting because if we go to the background, we notice that all we have here is when I receive message 1, play a note, but the time variable is not affected by message 1. Once you've clicked that green flag, it just keeps counting down. Let's go back to the ball. If it touches goal 2, which is this one over here, then again hide the ball, play a sound, change the cat score by 1 because it scored a goal, wait a second, make the ball go back to X0, Y0, broadcast message 1 to start everything again and show the ball. That is the ball script, and there can be improvements, and I hope you continue to make them and play around with these variables and instructions. Now on to the goal scripts. Goal 2 is very simple. This is goal 2 over here in this area, and it simply is go to 210 and Y0, and anything that has to do with a goal is covered in the ball script. So here is if touching goal 2, then hide, play sound pop, and change the cat score by 1, and so forth. Goal 1 is the same, very simple. Go to -210, Y0. So goal 2 is positive 210. Goal 1 was -210, which means it's on the left side of the 0. And you can see here that the goal is actually, you can see it's cutting the grids there, right there. And we can count 20, 40, 60, 80, 100, 120, 140, 160, 180, and that's 200. And it goes to -210, so that's in the middle. And that would be right here. This is -240, -220, -210 is right here, so that's the center of the goal, not the edge. It's the center of the goal. And we set that up when we made the goal. We go to the costume and you click on the centering tool. You see that the center of the goal is in the middle. You could have made it on the edge, but I always like to make them in the middle so that I have a standardized way of using my sprites. I always know that the center of a sprite is exactly in the middle and I don't use the edges. And that's a design decision that you can make. And that's it for the game. So enjoy the game, and there's some questions that are coming about changes that you can make, and I think you have some ideas over what I've just described. Thank you for watching. Thank you for watching. In this tutorial, we will be looking at the cat versus the mouse game. First, let's see what the field is like. We'll click on this screen symbol at the upper left-hand corner, and here we have our field. We can see that there's a soccer field that we drew using the paint program that's in Scratch, and we have 2 goal sprites, a cat sprite, a mouse sprite, and a ball sprite. When the game starts, the cat or the mouse will hit the ball and attempt to put it into one of the goals. When the ball sprite touches a goal, then the game is stopped and a score is increased. So at the upper left-hand corner, we have three variables that we created in the program. One is time. Time counts down from 60 by 1 second, so it is a 60-second game. And of course, you can change that in the program, in the script. We have a cat and a mouse score, and they keep track of how many goals are scored for the cat and for the mouse. We created this field, and these sprites are dimensioned according to the grid provided by Scratch. Let's minimize and go through this. First, we have our stage. The stage has two backdrops. So we start off with the backdrop for the game. Let's take a look at the script. Here we have a script, so we can have scripts for stages, and it's convenient to put variables such as time and maybe even sounds in this area so you can see them all at once. We only have two separate programs in this script. Here we have the starting script that's associated with the stage area. When the green flag is clicked, set the variable time to 60. And so when we were programming this, we went to the data area and created the variable time. We have a loop or a repeat structure here, and here are our line by line or sequential structures. Remember, there's three kinds of structures in any script or program. So sequential, loop, and inside the loop are two sequential instructions. Inside we see that we wait for 1 second. So this script waits for 1 second. It subtracts 1 from the time variable. So the first time it runs, the 60 will turn to 59 because it subtracted 1. And you repeat this 60 times. At the end of 60 times, you stop all, which means all the scripts in the entire area, the entire game, are stopped. Let's take a look at the data. So here's the data script area, and here's how you make a variable, and we've created three variables for this game: cat, mouse, and time. And notice that it doesn't matter what script you're using or which sprite you're using this variable for. They're always all shown under the data list. And you can change which variable that you're using the drop-down menu. And so here are the instructions associated with data: 1, 2, 3, 4. So one is show. Down here we have show, and that's what shows the variable on the stage. If you don't want it to show, then you would of course hide it. Here's how you change it. You can increase it, or if you put a negative sign in there, you can decrease it, as we've done up here. And like all instructions, you just simply drag and drop them into the script like puzzles. Over here we have another script in the script area, and it says when I receive a message, play a note number 60 for half a beat. And you can play with the note instructions to see what the notes sound like, or look at a reference to see which notes they are using musical notation. So somewhere, someone or some script must be sending a message for others to receive it. So this is like a mailbox function. You can think of it as someone posts a letter, and the letter has a message in it, and the message is received when it's delivered to some other area. So in this case, another sprite or another script. So the stage is not a sprite, and it can have scripts associated with it. Let's take a look at the backdrops and see if the script changes according to the backdrop. So the stage in this program has two backdrops. This is the soccer field. Let's go to the XY grid. There we have the XY grid, which we used to dimension or make sure everything has the same size according to what we drew on our storyboard for the game. If you remember, we have the grid on a storyboard and you counted how many steps the goals were, what size they were, how many steps the mouse and the cat and the ball were as far as size goes. And we usually use a horizontal to begin with in this case, and then we can also dimension the vertical. Let's take a look at the script. Oh, the script didn't change. It's the same script that we saw when we have the soccer field. This means that the stage has a script associated with it, or comes with a script, and it's the same script for all backdrops. It doesn't matter how many backdrops you have. It's the same script. So that's good to know. Let's go on to the other sprites. Here is our cat sprite. If you click on the eye, you get the information. You can rename it. So I can rename it cat from cat 2. And you notice that its positions x minus 120 and y 0. And the direction that it faces is 90 degrees, which we know is scratch talk for looking to the right. The rotation style is how the sprite can move. In this case, it can turn around all like in a circle, all the way around. The next option is it flips one side or the other. So it doesn't rotate, it simply flips. And this sprite means that, or this selection means that the sprite doesn't flip or rotate at all. Okay. Can you drag it into player? That means if you click a mouse on it, can you move it around the play area? And we're not going to select that. And here's the show button saying that please show the sprite when the game first starts. This does not always work. Some of you have already found out that the ball sprite disappears quite often. There's a way around that. Let's take a look at the script for the cat. First of all, we have the data showing from when we looked at the field, and we have the script area on the right hand side. It's a very simple script. When the flag is clicked, go to x minus 120, y 0, which is where the cat is sitting right now. And then from the looks instruction is show, just in case the little bug and scratch that hides these sprites for some unknown reason happens, we override that and we will show the sprite. So all our sprites will always be shown when we start this game. Then we have a wait instruction, and it's good to have a wait when you first start things so that the computer can organize all the other sprites together and everything can start at once. Then we have a loop structure, and this is a forever loop. So we have sequential structures and a looping structure. And the main instruction here is go to mouse pointer, so the cat sprite will follow everywhere where the mouse pointer goes. So this is the player operation, and the player will move the mouse and the cat will follow the mouse and hit the ball and play the game. Now let's take a look at our backdrops, look at the XY grid, take a look at the script, and verify that the cat is indeed positioned where it's supposed to be. So let's count the steps. Each division is 20 steps. So 20, 40, 60, 80, 100, 120. This is going to the left of the middle, or the 0, 0 mark. So we put a minus sign in front of it. So we verified that it is minus 120 steps away from the 0. The nose is right on the main x-axis, so it doesn't go up and down any number of steps, so y is 0. So you have x is minus 20, y is 0, and when we created this scratch sprite, remember that we used the centering. So if we go to the cat sprite and go to costume, remember we used the centering guide or tool to make sure that the center of the cat was right in the middle, and that's how we know where to position it or how it is positioned. Okay, so that's a fairly simple script. Let's go on to the mouse. Here's the mouse, and it's a bit longer than the cat script. The mouse script starts with when I receive message 1. So here is another example where we have an event and we receive a message to begin the script. As we'll find out if we look at the ball script, it's the ball script that sends the message, and it's called broadcast. Like in TV or radio when you broadcast something, here we broadcast a message. So the message is sent to all of the sprites, the cat, the mouse, the ball, goal 2 and goal 1, and the ones that have when I receive message 1 will have a script activated, or a script will run. Even the ball script has a when I receive message in it. Let's go back to the mouse. So the mouse receives a message, and when it receives a message, it starts its script. We have sequential instructions here. The first thing that we do is we have the mouse go to X90, Y0, which is over here, and we can count on the grid 20, 40, 60, 80. That's 100, so between 80 and 100 is 90, and that's the center of the mouse. And when we made the costume, that's where we centered the mouse. So the mouse is positioned properly. Then we have the show instruction from the looks menu. And we wait for 1 second, which is from the control menu or the control block area. And again, these are sequential instructions. Now we have a forever loop, which goes all the way down here. So you follow the loop here. So that's a loop structure. And it hugs 2 decision structures. So here we have a script that has all 3 structures that are used in structured programming: sequential, loop, decision. Line by line, repeat, if then. Our first decision is very interesting. Here's the question it asks. If the x position of the ball is greater than minus 180, where is minus 180? 20, 40, 60, 80, 100, 20, 40, 60, 80. So minus 180 is just past the cat's tail, and you can just see the goal here. It's white and it's breaking the grid lines. So it's just in front of the goal, which is goal number 1. So if the ball is greater than minus 180, so if the ball is before the goal, in front of the goal, and so the first part of the question is the ball in front of the goal? And if the x position of the ball is less than 170. So both of these have to be true for this sequential instructions in this decision structure to run. What does this mean? 170 is over here. So we know this is 240, 220, 210, 200, 180. So somewhere 170 is here. So somewhere between this area and minus 180. So if the ball is anywhere inside that area, greater than minus 180, less than 170. So if the x position of the ball is in that area, point towards the ball, have the mouse point towards the ball, and move 4 steps. If the ball is in the area in front of the goals, then the mouse will go towards the ball 4 steps at a time. The next decision is down here. And here's the question that it asks. If the x position of the ball is greater than 170 steps, then do all these instructions. So 170 is about here. So if the ball is to the right of 170, in other words, greater than 170 because 240 steps are over here, so it's before the goal or on the sides of the goal, then what do? Point the mouse towards goal 2. Goal 2 is here. So the mouse points its nose towards goal 2. Then we have a new motion instruction. That is the glide instruction. And the mouse will glide in 0.4 seconds, about half a second, to the coordinate x 185, y is 0. So the mouse will essentially go to the edge of the goal. And we did not use move steps because the glide instruction takes the mouse wherever it is and puts it to the front of the goal. So the mouse can be way up over here, and if the ball goes greater than 170, so it's in the area of the goal, then the mouse zips over to the goal front, and it's going to act as a goalie. So we use glide when we don't know how many steps that sprite has to move to get to a certain position. Then we repeat this 4 times. So here we have a decision structure, and inside of a decision structure is a loop structure or a repeat structure. And inside this repeat structure we have some more sequential structures. We have the instruction point in the direction 0. So direction 0 in Scratch Talk is look upwards. So the mouse nose will go upwards. Move 30 steps. The mouse will move up to the top of the goal. Wait 0.1 seconds, which is very, very short, or 1/10 of a second. Then we point in the direction 180 degrees down. So the nose of the mouse will point down because 180 degrees is Scratch Talk to look down or to go downwards. And move another 30 steps. So the mouse will go up and it'll move down 30 steps. We might want to change this to make it a better goalie, and that would be a good idea because this is not perfect. So there's room for improvement here. So let's recap. When the mouse sprite is activated by receiving a message, it positions itself, it shows itself, it waits for everything to set up. If the ball is in the playing field and greater than -180 and less than 170, then the mouse points towards the ball and goes towards the ball. If the ball is greater than 170, so anything in this area around the goal, so if the ball is above or below or in front of the goal, then we glide the mouse zips over to the goal, and here it goes up and down 4 times to act as a goalie. So that's a great little program for the mouse, and we can always improve it to make it a little bit better.